Hello and welcome to Norton Live Streams. In case you didn't know, this is a series of live streams we are doing here from Norton HQ here in the UK. If you've missed any of our previous streams, you can catch up with them on our YouTube channel, where you can find all of those live streams and lots of other information of abrasives, how to use them and best practice. So give it a look. Okay, so before we start this live stream today, I want to introduce to you a tool here on the Teams package, which is called Closed Captions. A little button on your desktop there on the Teams, a little cog icon. If you click on that, you can select the translation of my English into your local language. So that should help with your viewing experience if your English is not as good as it could be. All right, so let's. If you don't understand, just click on that, and it will help you a lot. So today's subject is rail cutting. Okay, so quite a lot of stuff to go through today in the next half an hour. So it's quite a tight window to get through a lot of information about this quite extreme application we're going to show you today. So we better crack on. Let's have a look at the agenda we're going to cover in the next half an hour. Okay, so first of all, we're going to introduce you to the experts who will be on the live stream here from Norton today. We'll look at the explanation of rail cutting and why we need to do this application. Then we'll have a look at the different types of rails that are out there in the market. We'll look at a few safety tips and technique tips of how we actually cut rail. We'll have a look then at some advantages of Quantum 3. And then we'll go into some what we call test expert data, which is a tool we use to record data when we do cutting or grinding tests. And then at the end of it, we'll have a live Q&A, so questions and answers. So to those of you who are watching this live on Teams, whilst you're here with us, on the chat, if you have any questions, just pop them onto the chat. And at the end of the live stream, after the end of the half an hour stream, we'll then come to that, and we can discuss these questions live together. So anything you want to ask us about rail cutting, pop it on the chat, and we'll get to it at the end of the stream. Okay, so as I said, we've got a lot to get through today, so let's crack on and introduce the experts who are with us today. First of all, it's me, Paul Gray. I live in Cheshire, in the centre of England. I'm an application engineer for MRO for the whole of EMEA. 30 years in total in manufacturing, and 20 years of those have been spent in the abrasives industry. Okay, I'm very happy today to welcome Ian Dixon, who's joined us in the studio today. Ian, would you like to introduce yourself?
I certainly would, and thank you very much for this opportunity. I really appreciate it.
My pleasure.
My name's Ian Dixon. I run the Rail Clamp Company, which is a rail-focused company based in the UK. I have about 43 years experience working in the rail industry, 30 of those years in the permanent way side, which is the track, stone and sleepers.
43 years, quite a bit of experience there, Ian.
It certainly is, yeah.
Again, thank you for being with us today.
You're welcome.
And online as well, not with us in the studio, but beaming in directly from the Netherlands is my good colleague, Derek Vrink. Derek, are you online?
Yes, good morning, everybody.
Good morning.
So just to introduce myself shortly, I'm Derek Vrink, and I'm the Senior Product Manager for cutting and grinding discs, next to other products as well. And one of those products within the cutting range is rail cutting, of course. And we have sort of specialized within Saint-Gobain in making high-performance rail cutting discs. So it's a pleasure to be talking to you about these.
Pleasure to have you with us here today, as not in the flesh, but in spirit and voice. Cheers, Derek. So, Ian, again, thank you very much for coming down today.
You're welcome. Thank you.
A great pleasure to have you here, and really do appreciate that. So one thing that's going to be a little bit different about today's live stream compared to what we actually normally do on the live stream, we normally do the applications here in the Norton studio. But due to the severity of this application, with the amount of dusks, the amount of sparks, the amount of debris that's ejected from when we actually do the rail cutting, we have actually recorded the footage of the cutting about a month ago down at Network Rail Training Centre in Bristol. So we won't actually be doing the cutting live in this studio for obvious reasons. But when we do show you the application, we will be showing you footage that we recorded with Ian down there at the Bristol Training Centre. So no live demos today, but we will link into them seamlessly, I should hope, today. Okay, so So let's get straight into it. We'll have a little bit. What we'll do today is have a little bit of presentation. We'll have one slide, and then we'll explain what that slide's about, and then we'll keep going that way. A different slide about different attributes of the application, and we'll discuss with Ian about why all these points are very important in this very, very extreme application. So first of all, let's get into it. Rail cutting and why. Okay, so rail cutting is done generally with a petrol saw. And quite standard for the market is a 350mm or a 14-inch abrasive blade used on this saw to cut through the rail sections. The reason they do this is for repairs or joining in new sections of rail when required. It's mainly done at night for obvious reasons, because they have to close down a rail track, so it wouldn't be popular to be doing that in the day. It's really focused on continuous welded flat bottom rail. This is where we do most of the cutting in the rail industry. And after it's cut, the rail sections are then tensioned, joined and ground flat. Okay, so back to us in the studio. So Ian, as we discussed there, rail cutting and why. This is the type of machine we're using, a petrol saw. So why would we be using a machine like this for rail cutting? What's the reason to use a petrol saw rather than a corded grinder, for example?
Well, this is the industry standard worldwide. Most rail companies now use two-stroke rail cutting saws because they're an independent, lightweight machine that's easy to carry to site. And I think you must appreciate that some of these sites, it's quite a distance from the access point to get to where you're going to work.
So difficult to trail an extension lead or a power cable 3 kilometres down a track to power your machine, right?
Absolutely, and the less equipment these guys have to take to conduct the weld and prepare the rail, the better.
Okay, so it makes sense to be using a machine like this. It's portable. It's relatively, I wouldn't say lightweight, but
I think they're about 24 kilos.
Okay, so not relatively lightweight. I wouldn't want to be holding that for too long down a track, but it's indispensable really because of the portability of the machine for this application. And the reason they do the rail cutting at night, again, is to stop disruption of the rail network, I guess.
Absolutely. The less disruption to the traffic, then the less compensation that has to be paid to the train operating companies. So they have very short windows of work, normally from midnight till the early hours of the morning.
Right. So it's when most of us are tucked up in bed. This is when the application is going on in the market.
Absolutely that.
Okay. Very good. Now, so we understand why they have to cut rail, and that's due to what is it? Just the rail's bent or the rail's broken? What's the reason they have to cut out sections of rail and put in new, for example?
Numerous reasons why. The major two are rail replacement when you're replacing long lengths of rail.
After a certain time period.
After a certain time period, and the rail is worn too far to be fit for purpose.
Okay.
So they have to renew it.
Right.
And the other reason is temporary defects. They often find defects in the rail that they have to cut out and then weld the rail sections back together by cutting the defect out.
Interesting. So once they've cut the rail to size, I then mentioned they have to be tensioned. Why do they have to be tensioned? Why are they just laid on the tracks and that's job done? Why do we need to tension that rail?
We tension the rail to reduce the amount of expansion and contraction due to weather change and heat change. So they find an ultimate temperature, stretch the rail to its ultimate point, which dramatically reduces the amount of rail movement in hot and cold conditions.
So say take the example of the UK, for example, we can have -10 here and we can have +35 in the summer. We can have a huge range of temperatures throughout the year. So that minimises the distortion of that rail in those extremes of temperature.
Absolutely.
Okay, it makes sense. Okay, so we understand why they have to cut rail, why they actually do that rail, the machine they're used on. So let's have a look at the different types of rail we have in the market and a few techniques that we use when cutting. So there's two main sizes of what we call flat bottom rail. As you see on the picture there, you can see the flat bottom of that rail section there. That's UIC 54 and UIC 60, which is an EU standard. And a little bit of tips, when you're actually cutting the rail, we must always ensure that you use the adjusted clamp when we're cutting. Really, really important not to be doing this freehand with the petrol saw. But I guess that doesn't happen in the market, Ian?
No.
No, thankfully.
Of course not.
Of course not. When you're actually cutting, we say always pendle back and forth. We'll explain this in a moment, what we mean by that. We say never cut over the top of the rail. Don't push. Just use the weight of the petrol saw rather than your muscles because it's a heavy beast. And always wear the correct PPE. So, Ian, again, the rail sections, we've got UIC 54 and UIC 60. Why are there two different types of rail? It's an EU standard, right?
Absolutely. These, and worldwide predominantly now. Most railroads, obviously from a cost perspective, for manufacturing the rail sections, they've produced the two. The UIC 60 is the larger rail section, so that's normally used where there's heavy traffic.
Okay.
So it lasts longer because of the extra size in the rail, and there's a greater time distance between replacement.
So it's bigger, more volume of material, so therefore you get greater life out of it. And here we have in front of us is a section of the UIC 60. What does 54 or 60 stand for? What?
It is the actual weight per metre of rail. So it's 54 kilograms per metre and 60 kilograms per metre.
So this is the one that's 60 kilos per metre of rail. Okay, no problem. So that's the different types. And you say UIC 60 is for the busier lines,
high wear areas where there's more traffic.
It makes sense. It's going to last longer, so you can keep that track running for longer using the heavier duty rail, essentially.
Absolutely that.
It makes perfect sense. Okay, so we know the different types of rail we use. This is by far the most popular size, I would say.
On main lines.
On main lines, it's the UIC 60. Okay. And so when we were talking about cutting the rail, a few tips about cutting the rail. First of all, we were talking about the clamp. So we've got the machine here, and we can see the big petrol saw. But when we actually cut, we must ensure we use this clamp here. Now, this clamp actually clamps onto the rail. We fix the machine onto this spindle here and tighten it on, and that holds the machine in a purely fixed 90-degree angle to the track. Or no, it's not. It's a 180, isn't it? So we're right in line with the track, parallel with the track itself. So you can see how that works. This controls the saw and makes sure you get a dead straight cut through your material. Okay. So also it much enhances the safety of the operation as well. There's no chance of getting out of control with the machine with this, because it's holding onto your machine, because it's, like I say, it's a real heavy beast. So this gives you a huge advantage, and that's been standard in the industry for a long time. This
for many years, since basically the early 90s.
Okay, so yeah, it's a fundamental. So when you're cutting, you must incorporate this this clamp here. All right, pop that out of the way a second. So we also talked about when you're cutting is a bit of technique when you're doing. So we'll show you an example physically. I mean, we can't actually cut in here, but we can show you how it looks. So when you're cutting a blade, we always start from the top of when you're cutting the rail, we always start from the top. Now, there's three sections to a piece of rail such as this. There's the top here, Ian, which is called the head. There's the middle section here,
the web,
and then the base section here,
the foot.
So the head, the web, and the foot. And when we start to cut with an abrasive wheel, we obviously cut from the head first. That's the highest point.
Absolutely. Okay. View it as one separate piece. So cut through the head first, completely through the head.
So we cut through the head first. And when we're doing that, what we don't do is just apply the blade in one area and leave it there and have that cutting through. What we must make sure we do is what we call pendle or oscillate. So we move this over the head of the rail as we cut. And the reason we do this, there's actually a couple of reasons why we do this. If we stay in the one area, we end up going into the material here, and we have what we call a very large arc of contact. Okay, so there's a lot of material touching the blade, effectively forcing a huge gripping area, producing a great deal of heat, and that's an enemy of doing this. We don't want to get this material hot, or at least
of the blade.
An enemy of the blade too. So we'll get this material extremely hot, we'll get the blade extremely hot, and that will wear more quickly. So if we oscillate, we reduce that arc of contact, therefore, increasing the pressure in a smaller area and actually cutting through the material a lot quicker. And, when we do put too much heat into this material and we start to blue this material, that's actually detrimental to the rail, right? That's a problem.
Absolutely. It changes the metallic structure and makes it far more difficult to do the finishing process, which is welding the two rail ends together.
Okay, so it's a real big no-no. If you see bluing, it's a problem. So we want to try and avoid that, and that's down to technique. So once you've cut through the head, you've gone all the way through here, You then get to the web,
top of the web,
and we continue to oscillate backwards and forwards in this part a little bit as well. And then
when you hit the base, when you hit the top of the foot, you bring the blade out to the outside of the foot.
Yeah.
And cut through the foot.
So then we go through
absolutely as you see there.
Yeah. And then what we want to do is have a blade that's big enough in diameter to actually go through the whole of this foot and cut off in one action. That's the ideal. So we get one cut without moving or taking the saw from the opposite side. We also said when we're cutting, we never go actually over the top of the blade and cut top of the track and cut from the opposite side. And that's a big no-no in the market as well.
Absolutely, always from the one side.
And the reason is because of lack of control.
Absolutely, pinching of the blade.
Yeah, the spraying also the debris up into the air for the overhead cables is also not a great thing to do. So we have to make sure we get through from this side and then dismount if the blade's got small in diameter, we dismount and we go again from this side and we go through the foot first again and meet where...
To complete the cut.
To complete the cut, that's the best way to say it.
Absolutely.
Okay, so that's a little bit about the top tips for cutting. So I think I think at this point we'll talk quite a bit about why we cut the rail and techniques to do that. So I think it's a good idea for us to have a look at the video we recorded a month ago down a network rail in Bristol with the operator Lee Janchessen on the machine. I hope he's here joining us on the stream, watching us live. So. Thank you for this video, Lee. Run VT, please, Martin. So here you see the oscillation over the top of the rail there, going back and forth. I don't know why you can still see us on here as well, but yeah, it still looks good. We're going through the head of the rail material. You can see nice oscillation, a lot of sparks. You can see that there. You now understand why that's much better. Thank you, Martin. So you can see why we don't do this indoors here in our studio. A lot of sparks, a lot of debris. So now we're through the head, and now we're cutting very quickly through the web of the rail. And now we're at the foot of the rail now, and then we do exactly as you said there, Ian. We pull out, and then we start on the
outer edge of the foot.
And
work through. You
see the rail clamping operation there as well, holding the machine straight and true. All in all, this cut takes about 1 minute with a Quantum 3 blade that we're showing you today, which is a really fast speed of cut. Again, look at the sparks. It's
and I think the point to note is that this is UIC 60, the larger rail section you're seeing here.
Yeah, so this is why we have a 350mm diameter blade through this, so you can get a couple of cuts from the blade without actually swapping the machine over to the other side, which is crucial, isn't it?
Certainly helps the operator.
It does indeed, because we don't see that from other blades in the market without a doubt. So that's the biggest section of rail. That's the toughest application out there for the wheel. So we've shown you again now, why we cut rail, a few tips and hints. We've shown you actually the operation. So we're now going to have we're going to show you our wheel that we used in these tests, which is our Quantum 3, and we're going to show you why it's so good, why it's really good at this application. And Derek, the product manager, is going to explain the attributes of the wheel to you now. Thanks, Derek.
Yes. So if you take there's something about ceramics. Ceramics are becoming more and more popular in abrasives these days, and that has a reason. Typically ceramics are at least 3 times more efficient than regular grains that you will find in abrasive blades these days. So they bring 3 times more productivity, really, at least we say. Right? If you use them well, you could get more out of these. And the combination between the bond and the actual grain is giving this disc a very long life, where normally life and speed of cut do not go together. But typically, the combination of ceramic with this bond, it gives both speed, as you say, Paul. It's a 1 millimeter cut, 1 minute cut, which is very quick. Normally you would take 1 minute 30 would be the normal regular type of time that you would take, and And that's a big improvement, and it delivers really a sharp cut throughout the three cuts that you would be able to make from one side if used correctly. I'm going to be very strong about that, because
Yeah,
you see
I think that's
that,
important, Derek, if used correctly, yeah, because we do see people that don't use these products correctly in the market and don't get the
yes,
maximum out of their wheels.
yeah. And that's normal, because the circumstances on the rail tracks, right, in the middle of the night, it's almost always raining. You need to do
In
the
England,
job
definitely.
quick. Yes, and in the Netherlands as well. So the
Yeah, true enough.
circumstances are relatively rough, and people are tempted to cut corners on the applications, right? And that doesn't work for abrasive blades in these, for any abrasive blade really. But if you use it correctly, you can really get at least 3 times more efficiency out and productivity out of this disc, in comparison to a regular aluminum oxide disc that you find in the market today.
Well, I think we'll have a look at that now then, Derek, about exactly what you say, how the performance benefit differs between our Quantum 3. And we've got a good example of that in front of us here on the table. We've got blades in different states of usage in front of us here. So here we have our Quantum 3 and a competitor blade, brand new. Okay, so these are both 356 millimeters in diameter. Brand new blades, 14 inch if you like as well, if you're still an Imperial. Okay, so these are how they start out at new. Now here we have a blade of each, again our competitor and our Quantum 3, that has performed one cut. So that's just one cut of rail. And you can see there the difference in diameter of the competitor blade versus the fully ceramic Quantum. You can see if I center these perfectly in the middle there, we can see there's extra diameter on the Quantum product out there than there is on the competitor product. And if we move over to the left-hand side of my bench here, we again have the Quantum 3 disc here, which has managed 8 cuts, and we have our competitor blade underneath. Again, they're pretty much the same diameter, if you like. Sorry there, Martin. Martin's trying to zoom in on me moving these blades around. So very much same diameter. So we got 8 cuts from the Quantum and 3 from the competitor. So here's your 3 cuts from the competitor blade here, and over here we have 8 cuts from the Quantum. So we end up at the same diameter, which is about 300 millimeters. At this point, you can't effectively cut anymore because you can't get through the foot of the track from either side. So now at 300 millimeters, that's scrap. But
Time to change.
yeah, time to change, time to get a new blade on. But 8 cuts versus 3, it's very obvious that the performance difference that you get there. And that's all down to the bond technology and the ceramic grain inside the Quantum 3 cutting disc. Okay, so we'll have a look now. Thank you very much for that, Derek, about the key benefits that it gives you, some of which Derek brought up in his when he was talking about Quantum 3, but we'll go into them a little bit further. So these key benefits we'll show you now on the screen. 9 in total. So more cuts per blade, as we just spoke about. Operator comfort, which is a big factor these days with increasing attention to HAVs or hand-arm vibration injuries. Reduced cutting time, really crucial. We'll explain that later. Typically 60 seconds for the Quantum 3. Very, very important factor. Reduced cost. Everybody's looking to reduce cost these days, so it's always a benefit. Reduce waste. Again, you know, everybody's looking at how much we're throwing to landfill these days, so it's very important. Also, for the next operation, welding the rail together, perfect straight cut. Less than 1% horizontal and vertical deviation is absolutely paramount for the quality of the cut. Quality cut every time, no burn. We did allude to that earlier. We'll go into that a little bit later on. Also, less wheel wear, less dust, so more pleasant for the operator and the surrounding neighbours, and less noise at the end of the day, okay, because we're cutting quicker. Okay, so Ian, we'll just go through each one of those 9 advantages we get from the Quantum 3. And the first one of those was cuts per blade. Why is that important for an operator out there on trackside?
Well, there are 2 reasons really. Firstly, we have the time element, where obviously if you're using more blades, it takes time to change the blade on the machine.
Yeah.
And the other aspect is safety. You must bear in mind that these 2-stroke machines get very hot. They have to be refueled sometimes partway through a job, and you don't really want to be changing blades, refueling with heat which can cause fires line
You've got
side.
hot engine, hot exhaust.
Absolutely.
It's night, and you're trying to pour fuel into the machine. So if you have to do that less, there's less risk of this too.
Absolutely, less risk of accidents.
Also, I think if I'm an operator as well, you know, when I get trackside, I've got to carry all of my equipment to the area where I'm actually doing the job. These blades are not light. A box of 10 discs, probably about 20 kilos or something like that. It's not too heavy to carry a small distance, but when you're going 3 kilometers down track to actually working, the lighter the better, or the less blades you need to use for your cutting, the less you have to carry. So that's quite a nice option you have there. So yes, more cuts per blade gives you quite a lot of advantage there. Now we also spoke about operator comfort. Okay, so you know we're getting through there quicker. There's less vibration in there because they're cutting quicker. Why is that important now with HAVs?
Well, absolutely. I mean, the issue here is that because the operator is cutting through quicker, he's less exposed to the HAVs of the machine.
Yeah.
Also, as you said, the comfort factor, there's less vibration through the machine completely to the operator.
Because we're slicing through the rail, because the blade's doing the work quicker, it's cutting smoother, and this machine itself creates a lot of vibration with the motor inside.
Absolutely, through the motor as well.
So less time exposed to that. Better for every operator using these cutting machines.
Absolutely.
Okay. Next one we had on there was speed of cut. Okay, so obviously speed of cut means they get the job done quicker for a start. That's always going to be an advantage. What other advantage does that speed of cut give us?
When they go to these work sites, they have a very tight work schedule time-wise. So the quicker you can get the cut done, you get more time to finish the operations that come after.
So you mean the window of when they can close the track to when they need to be opening the track the following morning, right? Because remember, it's always at night, yeah?
Absolutely.
There's also we were speaking about this earlier. There's also the thermal expansion and contraction of rail as well. If you're taking time to go through that part of rail, you're pushing that 4 millimeter thick blade through that rail. There can be a problem with that also if
Absolutely.
you're taking too much time.
With the higher extreme temperatures we're seeing now in certain geos, the problem you have is that as you're cutting the rail, when the air is warm, the rail is expanding as you're cutting it due to the ambient temperature of the rail.
Because you've got 100 meters of rail either side of this,
Absolutely.
right?
They unclip hundreds of meters to cut.
Right, okay. And that expansion can actually tighten the gap where you're cutting as you're cutting, and effectively what we call pinch the blade, which means you stop the blade when in the material.
Absolutely,
which is not ideal.
Completely stops the blade.
You then can have a breakage, or you've got to then try and get the wheel back out and then start to cut again, which again takes more time. So speed of cut really crucial. Reduce cost. I think that's evident. You know, with obviously ceramic grains are going to be much more expensive than a conventional aluminium oxide. But when we look at the amount of cuts you can get for the blade versus the standard aluminium oxide, I think that the cost is greatly reduced of the whole application, even to the quantity of blades you need to buy every year. And we will have a look at that a little bit later when we look at our test expert program, and which Derek will go through with you. Now, waste is also a big factor for any organisation. Now, we all have to account for how much we send to landfill. So imagine, you know, with these blades, if you're doing sort of 15 cuts, you're going to be using how many of these?
Probably 15 blades, to be perfectly honest.
15 blades,
to be frank.
Okay, but with this, we're going to be using perhaps 2. Okay?
Yeah.
So less blades sent off to landfill is always going to be a big bonus for everybody, right?
Absolutely.
Yeah, and everybody's targeted on reducing this, even in our own household. So a very important factor. Now, we were talking earlier about using the clamp that we have here and the machine, and how important straightness of cut is. And that's, again, due to the strength in the blade, that we don't get any flex in the cut when we're cutting through this material. Why is that important here? Why is the straightness of that rail important, that we've got it perfectly horizontal and the vertical angles correct?
Well, one of the major operations after you've cut is to, as you say, tension the rail and then weld it back together.
Yeah.
The welding process, the strength of the weld is determined by the rail and penetration of the weld. Mm-hmm. And if you have angles or burrs, then you don't get the same rail and penetration throughout the whole circumference of the rail head itself and the rail.
Right. So if each part of the rail, the part you cut and the part you're trying to join on, are not exactly parallel to each other, that's going to cause an issue when you're going to weld.
Absolutely.
It's very simple. Now, I think we've got a little video about this, how this is measured on trackside, and we'll have a look now at how the cut should look and how it's checked out there on track for this attribute. Martin, if you can run VT, yeah. There you go, here's a section of rail that's been cut. So what we're measuring there, Ian?
You're measuring the straightness there horizontally and vertically.
As we see,
Straightness of cut.
Perfect 90 degrees on each one of those. Really, really, really important. I mean, we can have a look at a couple of examples that we did when we were cutting there a month ago. Here is the cut here. If you can zoom in there, Martin, that's a good challenge for you. I didn't tell you we were going to do this shot. Apologies for that one. Here's the cut done by Quantum. As you see, it's very nice. No edges on there. And here is one done by the competitor blade. And you can see we have a step there. How can you get to that? There we go. We have a step here where that blade has not cut straight when we've gone through from the other side. That's a problem. Okay. When we go to weld that, it's gonna cause us some issues. We also see a lot of burrs on here as well. So yeah, not ideal. So yeah, important to get the cut right and get it right first time. Again, we're saving time by doing that, saving rework. Clean and no burrs. So we had a look at the rail section there as well on the previous shot. Really important to have no burn on the air, as we explained earlier, for the quality of the weld, right, Ian?
Absolutely. It's down to the quality of the weld again. If there's bluing, that means the metal structure has changed where the heat has been put into the rail.
Yeah. And if we've got any burrs on the rail once it's been cut, they have to be ground off as well, don't they? So they've got to get there.
They do have to be cleaned off.
Yeah. So again, it's more time. So if you can get a cleaner cut with no burrs and no burn, it's going to, again, better quality weld and save you time cleaning off that burr. Next one to look at is dust and noise. We can do that in one, I would say. Oh, sorry, I forgot about the VT there, about the clean cut. Thank you for that, Martin. Martin's here running the show today and reminding me to do exactly what I say I'm going to do. So yeah, as you can see, that cut of rail, absolutely clean, minimal burrs and no burr or bluing.
No bluing
at all. So that's what we want from every cut, from the start of the blade to the end of the life of the blade. Really important. So last 2 points were noise and dust. So why is that important? The guys are out in the middle of nowhere, cutting rail next to some cows in a field. Why is that important, Ian?
Well, there's a health and safety reason here, obviously, for the operator. The operator doesn't want to be exposed to too much dust, too much vibration. There's all of that. Also, you must bear in mind that obviously in the inner cities where this work is being conducted, it's not only the noise to the operator, but it's the noise to the residents living around the work.
So the trackside neighbours, we can call them.
Trackside neighbours.
Yeah, the noise and dust. So none of us want to be hearing petrol saws screaming at
2 a.m.
2 a.m. in the morning when you're trying to count sheep. Not ideal. Okay, so dust and noise, really important factors. Right, I realise I've been waffling quite a lot, and we're running out overtime a little bit, but hey, live TV, we'll just have to stick with it. A little bit I want to show you now is what we call our test expert program. So these are the tests we did down in Network Rail in Bristol with Lee, the operator down there, and of course Ian as well was there too, and showing the performance differences of Quantum 3 versus our two main competitors in this market. Derek will take you through the results as you see here on your screen. Over to you, Mr. Brink.
Yeah, I will go quite quickly. We have this test expert tool in place to visualize the actual performance of our products, and also this test expert tool will give you an idea, or will give you the arguments as to why performance always wins. Performance always wins because your end user is going to be more happy with a better product. Secondly, your company is going to be more happy with products that you have to buy less, right? So where you would use 3 competitor discs, you would need to buy 1 disc in Norton Quantum 3, for instance, or even our Zirconia discs. So that's the reason why we developed Test Expert, and it gives a real clear vision of where we stand with our performances versus our competitors. So it's really benchmark tool.
It's very clear on the graphs here, Derek, isn't it? 1 cut from competitor 1, 3 cuts from competitor 2, 8 from the Quantum 3. It's night and day difference. It
needs no explanation, I would say.
But then we're always interested in costs, aren't we? So if we look at the next slide on Test Expert, makes it very clear, Derek.
Exactly. So if you go to the and look at where the costs are, if you can imagine, if you can make 3 or 4 cuts with one disc, and one cut with a competitor disc, it saves you 4 times changing a disc. Again, this is done at night in severe weather, in not so nice conditions. So you would like to prevent that from happening, and that's where the majority of the cost will take place. So the wheel change cost, as well as the labor cost, which wheel changing is labor as well, will go up the more the more you have to change your discs, actually, right? What we're showing here is, of course, the Norton Quantum 3 in this whole live stream. You have to consider that this is by far our best disc. Our second best zirconia disc, for instance, will not be so far off. So it will be it's a different choice. It acts a little bit harder. But if you take the Test Expert, it really depends on the man, the machine, and the material that you're cutting. And in the end, what disc do you want to use in your application, right? That determines if you are successful, yes or no, and if you are going to see any costs visible in this test. If your machine is not well maintained, you can forget about the absolute best disc in the world to work for you, right?
Yeah, an application, as you say, Derek, is only as strong as its weakest link. So it's really important. So you can clearly see the cost benefits from using a high performance product. So it's cost, and it's also operator ease, operator comfort, quicker, easier to use.
Yes, and especially, Paul, if you look at the amount of rail disc that you would use in a complete season. It's split between 2 seasons, spring and also in the autumn. You would see a lot of rail cutting taking place. In the midsummer, it's too hot, most likely. But
yeah,
this is typically where you see the amount of discs that are used is enormous, and if you can save money, it goes up very, very quickly.
It's always an important factor.
Yeah.
Thanks for that, Derek. So I think we can show you now a video from again, we recorded in Bristol last month. And this is kind of a testimonial from Lee Janchesson, who's the training manager for the Bristol training, the Network Training Centre, Network Rail Training Centre down in Bristol. So he's the guy in charge of training all of the new employees at Network Rail. And I asked Lee, after a day of using our wheel versus the competitor, what he thought. Run VT mine. So how you doing, Lee? So would you like to introduce yourself and tell us what your responsibility here is at Network Rail?
So I'm Lee Janchesson. I'm the training delivery manager for the Wales and Western region. Mm-hmm. Been on the railway just coming up to 33 years, 13 years out on track as a track operative and then track welder. And for the last 20 years been in training where I've trained numerous disciplines, so track engineering, track welding, and portable plant. Great.
So, Lee, you've been using our Norton Quantum 3 blade all day here today versus your standard blade that you use. How did you find it?
So current discs would be 1 cut from one side and then an additional 2 cuts.
So that's 3 cuts in total from the blade you normally use.
The discs I've used today, I managed to get 2 cuts from one side and then an additional 6 cuts cutting from both sides.
So with the Quantum 3, you achieved 8 cuts with 1 blade.
And a good quality cut as well.
Yeah, so did you see any evidence of burn or straightness of cut? Was it what you were looking for?
Yep, so it was nice and straight. There was no bluing, no burring at all. There was no evidence that the disc was overheating or heating the rail too much. So it had a really nice, clear, glass-like finish when we'd finished cutting.
So what about the comfort factor?
So they were really comfortable to use. There was no tying or binding when we were cutting. So the cut was clean and consistent every time, regardless to how much the disc had diminished. It didn't seem to lose any of its cutting power.
So, Lee, given a choice, which blade would you prefer to use, your standard blade or the new Norton Quantum 3?
I'd prefer to use the new disc.
Okay, thanks for that, Lee. So, To summarise, Norton Quantum 3, 8 cuts per blade versus the standard 3 cuts you get from a normal blade. Improved comfort, improved safety, improved speed. Couldn't get better than that. What a perfect result. Thank you very much. Great, Lee. And again, thank you for the day we had down at in Bristol with you. It was much appreciated. So, I mean, we say in England, straight from the horse's mouth, we can't get a better result than that. Lee, training manager for Bristol and Network Rail, really enjoyed using our product versus the standard blade he normally uses. Yeah, it was a good day.
Very good day.
Yeah. Okay, so I know we've run over a little bit on time today. I do apologise for that, but so we better get on for a little bit of a summary of what we've had a look at today. So, again, Norton Quantum 3, it is something different. Full ceramic technology, longer life, more cuts, more comfort, more speed, less dust, less debris, less waste, reduced cost. Everything you want in a blade for cutting rail, essentially. It's a very, very impressive product. On the screen here, you can see a QR code. If you scan that into your phone, you can download our Norton Industrial Catalogue, which has obviously in there the Quantum 3 rail cutting blade range, also our zirconia range and aluminium oxide range, but also a whole host of products, including our Quantum 3 cutting and grinding discs for angle grinders, etc. It's a huge catalogue with a lot of products in there, so please scan that and download the catalogue. I'm sure you'll enjoy it. Okay, so me and you will be together at Network Rail, Rail Live.
Rail Live next week.
Next week, down in, where is it?
It's in the, you've caught me there.
Yeah,
just
no
outside
idea.
of Stratford-on-Avon.
Okay, just outside of Stratford-on-Avon. Yeah. So we'll be there at
Long Marston.
Long Marston. So looking forward
Fridays.
to that, where we'll be showing our blade at this show. So yeah, I think it's about time we end there. So for those people who are watching here live with us at the moment, please stick around till the end of this, so we can do our live Q&A session at the end. But for those who are watching us on YouTube, we'll see you next time. Thanks again, E.
Thank you very much.
Cheers. Bye-bye.
Cheers now.